Hi, my name is Jashwant, and this here is the heart. The hearts of all vertebrates in of a death beat for some time. Take a fish heart for example. Even though it is detached from the fish's body, it still beats for some time. This shows that heart beats due to an internal signal. A signal which is produced by the SA node and passes to the AV node and finally through the Purkinje fibers. In this video, we will see how the signal is produced and how it travels throughout the heart. First, we will take a look at a cardiac muscle cell. This is because the SA and AV nodes and the Purkinje fibers are all made of modified cardiac muscle cells. The sarcolemma is a specialized cell membrane of a muscle. The sarcoplasmic reticulum stores calcium ions and releases them when required. Generally, this helps in muscle contraction and relaxation, but in the case of cells of the SA node, AV node and Purkinje fibers, this helps in increasing membrane potential, but more on that later. Myofibrils are the largest unit of a muscle which contract and relax. They are made of sarcomeres, which are the smallest contractile units of a muscle cell. T-tubules help in transporting both calcium ions and the signal to release those calcium ions into the cell. The SA node generates a signal which makes the heart contract. Based on where the signal travels, the heart contracts. The AV node delays this signal by 0.9 milliseconds. This delay helps to make sure that the ventricles get filled. Now the signal reaches the ventricles. The Purkinje fibers send the signal throughout the heart. The channels which will be mentioned in this video are voltage-gated potassium channel, hyperpolarization activated cyclic nucleotide gated channel, voltage gated sodium channel. Sodium calcium exchanger, L-type calcium channel. T-type calcium channel. Phases of the heart's pacemaker cells. Phase 4. The cell is very negative. The voltage-gated potassium channel is closed. Hyperpolarization activated cyclic nucleotide gated channel is open. The sarcoplasmic reticulum gets activated and releases calcium ions. The rise in calcium ions in the cell makes a sodium calcium exchanger to continuously release one calcium ion for 3 sodium ions. Cell is getting more positively charged. This activates L-type and T-type calcium channels. L-type calcium channels open very slowly. Along with this, voltage-gated sodium channels open. Phase 0. The L-type calcium channels are fully open. Hyperpolarization activates cyclic nucleotide gate channels and T-type calcium channels close. Voltage gate sodium channels go from their open state to their inactivated state. The sodium-calcium exchanger operates in the opposite way, that is taking one calcium ion for 3 sodium ions. Phase 3. The cell is very positive. After depolarization, the cell reaches action potential. Depending on the type of cell, it undergoes a plateau stage, then repolarization, or directly undergoes repolarization. The L-type calcium channels close. The sodium-calcium exchanger again reverses, releasing one calcium ion for 3 sodium ions. Voltage-gated sodium channels go from the inactivated state to a closed state. The sarcoplasmic reticulum starts to absorb the calcium ions present inside the cell. The voltage-gated potassium channels open to show how pacemaker cells send messages. So this is to understand how Purkinje fibers send signals. Here are 3 cells. So let's say the first cell generates a signal. The first cell right now is neutrally charged. By charged I mean the amount of cations and anions in the cell. The cell depolarizes itself and reaches action potential. It now influences the cell beside it to do the same. Now the second cell is also depolarized. It influences the third cell while the first cell begins to repolarize. The third cell influenced by the second depolarizes. The second cell influenced by the first begins to repolarize. Now the first cell, while depolarizing, will reach a point of where it is neutrally charged. There we can repeat this cycle. And there you have it, the process by which the heart sends a signal.